We've all seen it on TV, right? Some detective finds a smashed-up laptop, hands it over to a tech genius in a lab coat, and bam, just minutes later, every single deleted file is magically back on the screen, case closed. It's that classic CSI effect, and it's taught us all to believe that digital data is permanent, that there's always a digital ghost lingering somewhere, but what if that's just not true anymore? What if the evidence itself has learned how to vanish?
So I want you to really mull this over, because the very technology that's probably sitting inside your computer right now, well, it might just be making digital evidence recovery a thing of the past. And to understand how this is even possible, we have to look way beyond the Hollywood version of forensics.
To really get why this is happening, first we need to draw a hard line between the TV fiction and the forensic facts. See, real-world digital forensics isn't about some kind of magic trick. It is a serious, rigorous, scientific discipline.
And the official definition here really says it all. The key words are scientific methods and legal proceedings. Every single thing an investigator does is going to be scrutinized in a court of law, so precision and accuracy are absolutely everything. A case can literally be won or lost based on the integrity of that digital evidence.
And framing it this way is so important. Digital forensics isn't some weird niche tech field. Nope, it sits right alongside heavyweights like forensic DNA and pathology. Each of these fields has incredibly strict, standardized procedures to make sure the evidence is trustworthy. And digital forensics? It's no different. It has a playbook.
So what does that playbook actually look like? Well, for decades now, investigators all over the world have followed a very clear, very structured process to make sure the evidence they collect can actually stand up in court.
It's like this 6-step dance. You identify potential evidence, then you preserve it so it can't be changed. Then you collect a perfect bit-for-bit copy, and only then do you get to examine, analyze, and eventually present your findings. Now, the cornerstone of this whole thing, the most critical step, is preservation. You have to guarantee that the original evidence is never, ever altered. And for years with traditional hard drives, that was totally doable. Until the storage itself decided to change the game.
So what changed the game? The solid-state drive, or SSD. On the outside, yeah, it looks pretty much like a regular hard drive, but on the inside, oh, it is a completely different beast. It's an active participant that can, and as we'll see, does act all on its own.
I mean, this comparison really says it all. A traditional hard disk drive, an HDD, is totally passive. Think of it like a library book. It just sits on the shelf and doesn't change a thing until a librarian comes along and writes in it. But an SSD is an active device. It has its own brain, its own internal processes. It's more like a librarian who's constantly, quietly reorganizing all the books on the shelves, even when the library is closed and no one's around.
So, take one of those processes. To stop its own memory cells from wearing out, an SSD uses something called a flash translation layer. Just think of it like a hotel manager who's constantly moving guests to different rooms every single night, just to make sure all the beds get used equally. The computer and you, the user, you have no idea this is even happening. The drive is managing its own data completely behind the scenes.
But here's where it gets really, really dangerous for forensics. To stay fast, SSDs have to constantly clean up after themselves, and this process, called garbage collection, actively seeks out and erases blocks of data that it thinks are no longer being used, like the leftover pieces of deleted files. From the drive's perspective, this is just efficient housekeeping. But from a forensic perspective, it's a self-destruct sequence for evidence.
Okay, so this isn't just some theory. Researchers decided to put this to the test in a real controlled experiment. They took a classic HDD and a modern SSD, they did the exact same things to both of them, and then they just watched to see what happened next.
Just look at this graph. It is astonishing. That purple line way down at the bottom, that's the traditional hard drive. The deleted data stays perfectly stable, 100% recoverable, exactly like forensic investigators would expect. But the other lines? Oh, that's the SSD. About 3 minutes after just being powered on, with 0 commands from the computer, it starts to wipe itself. And in another 3 minutes, the recoverable data is almost completely gone. It's literally corroding the evidence right before your eyes. Let's put a hard number on that. In the forensic analysis after the experiment, a staggering 99.997% of the original file data on that SSD was just gone. Permanently, utterly unrecoverable.
And the hard drive, the old school one? Under the exact same test conditions, 100% of the file data was recoverable.
I mean, the contrast could not be more stark. The evidence survived on one, and it was systematically vaporized on the other.
Okay, so the obvious question for anyone in the field is, wait a minute, what about our standard tools? A write blocker. That's a device that's supposed to create a one-way street for data. It lets an investigator read from a drive without any possibility of writing to it or changing it. It is the gold standard for evidence preservation. Surely that would stop this, right?
And the answer is a shocking no. The researchers found that even with a hardware write blocker physically attached, the SSD could still be triggered to run its own garbage collection routine, purging massive amounts of data. And the crucial point is, the commands aren't coming from the computer, they're coming from inside the drive itself. The write blocker, the very tool designed to preserve the crime scene, was totally powerless to stop the evidence from destroying itself.
So, what does this all mean? The very foundation of digital evidence recovery, this core idea that deleted data sticks around and can be found, is being fundamentally challenged by the hardware that we all use every single day.
The researchers who conducted these experiments, Graham Bell and Richard Boddington, they did not mince words. Their conclusion is a really sobering one for law enforcement, for investigators, for the entire legal system. This isn't just some little technical problem. It is a potential paradigm shift. And that just leaves us with this final massive question. For decades, we've relied on digital trails to establish facts and deliver justice. But if the storage media itself can actively, automatically erase its own history, often without leaving a trace, how do we prove what really happened? What happens to our very concept of digital truth when the ghosts in the machine learn how to vanish for good?